Trusted your word, believed in your quest. Now I see though, just like all the rest. Trusted your word, believed your lore. Now I see through, can't trust you no more. Psychologically abused since I was a kid, believing your stories, the things that you did. Now I'm asking for my money back. I have it tallied up, 800,768 fiat dollars. Gave you my trust, followed your way. Now I see though, deceit on display. Now say you've been lying to me. Lies and deceit, it's all I see. Now so you've been lying to me, but deception's a game you played every day. Lies and deceit, it's all I see. Your fake streams and false reality. NASA, you've betrayed my trust with your fake streams. Stop being blind, admit your unjust lies. Since I was a kid, you fed me lies, stories and fables. Now I realize, meant for the masses to be force-fed to the blind. NASA, you've been lying to me with your fake streams and false reality. Your lies and deceit turned into dust. You've taken my trust through your lies and deceit, turned into dust. Trusted your word, believed your lore. Now I see through, can't trust you no more. Gave you my trust, followed your way. Now I see though, your deceit on display. Now say you've been taken from me. Lies and deceit, it's all I see. Now say you've been taken from me, believed in your quest. Now I see though, just like all the rest. Trusted your word, believed your lore. Now I see through, can't trust you no more. All I see.
The curve obstruct the boat.
The part where you're seeing it obstructed. What's so hard to understand about this? You look out, you see a ship.
Okay.
You're standing on the beach. Just let me finish. No. Let me finish making my point, and then you can respond. Okay. You're standing at the beach. You look out, you see a big tanker, not some tiny little sailboat, a big tanker, and it's half obscured. Right. You can only see from the railing up. You grab your camera and you zoom in. No more of that ship becomes visible. You can still only see the railing up.
Have you done this? Because there are multiple instances. Have you done this yourself? Because there are multiple instances of it being done.
Projectotron. There are none.
I mean, you can just say that there are none, but there's literal evidence of it being done.
Then you put it in the Jumbotron then.
All right, real quick, Roundhound there.
Yeah, Mark's got his hand up.
Well, I had my hand up. I was waiting.
I mean, I kind of jumped in, Vaughn. I'm sorry. Mark and Sydney have been very patient.
Not Shane.
I'll go. I have to go. I've got things to do.
He's up here.
I'm not ready
yet. I've got a question for you.
Okay, go ahead.
Okay, you're a clever cookie, and I'm going to ask you a question, and don't feel stupid if you can't answer it, because P-Dubs couldn't answer it, Big Tech couldn't answer it, Peter couldn't answer it. Okay,
no
so if you
I'll give my honest answer.
Right, so you're a clever cookie. You probably have more than a rudimentary knowledge of your heliocentric model. And before I go there, Ken, I do commend you for trying to argue refraction with these people, but it is their last leg, and they will defend it with their life. It is their wild card, and it's just hard to break through on that. So, but I will give you an optical proof that does not depend on refraction as a variable to disprove the heliocentric model. Okay. Have you heard, Sir Roundhound, of the Analemma? Have you heard of the Analemma?
Yes, I have. I
Okay.
know what the Analemma is.
You know what the Analemma is. So can you please describe why one loop of the Analemma is 4 to 6 times smaller than the other one if the ellipse of the Earth around the Sun is only plus or minus 3% off a perfect circle and plus or minus 3% speed differential from the fastest speed to the slowest? Why does why isn't that reflected in the Analemma, where it's more of a 6x difference, not a 3% difference? Can you please explain that?
Yeah, the distance of the sun is no factor in the difference on the ends of the Analemma. It's your latitude. It's reversed in the southern hemisphere to the northern hemisphere.
Yes, right. So in the southern hemisphere, so to speak, we have the Tropic of Capricorn. In the northern hemisphere, we have the Tropic of Cancer. And give or take a little bit, they're pretty much the same circumference, right? So the Analemma is a reflection, is a representation of the traversing of the sun across the tropics, across the equator to the other tropic, right? And so the intersection in the Analemma, the X in the figure 8, that's the point where it crosses the equator on the equinox. And the edges, the outside edges of the Analemma is the time the sun spends directly over the solstices. So if the tropics are the same distance, so for the most part, why aren't the lobes of the Analemma the same size?
As I'm not an expert in the Analemma, but it's based on your it's a viewer perspective. It's based on your latitude. It's not that they don't look the same from everywhere. If someone at the North Pole did the Analemma, it's going to look different to someone doing it at the
But
South
actually,
Pole.
what if I was to tell you that it does look the same from the north to the south, and perspective is not a factor? That when the sun
I'd
is
have
closer,
to take your word for it and try
well,
and
you don't have to take my word for it. I'll post a picture of the Analemma in the north, and
okay.
if the Analemma in the north had anything to do with perspective, that the top loop, which is the northern summer, would be closer, but on the Analemma it's smaller. So if it was closer, if perspective was a variable, it'd be larger, but it's smaller.
I'll look more into it, and hopefully next time we rub shoulders, I'll
don't feel
have a more
stupid, because
concise
I can hear you're acting pretty smart, thinking you know everything about everything. So don't feel stupid, because the other guys couldn't answer it either, and they still just so you know, after 2 months they still haven't answered it, and they run away from this one because they can't answer it. What I'll do, I'll DM you a picture of an Analemma. Actually, just Google it, right, and then try and work it out and come back with your answer.
Sure.
That'd be great. Thanks.
Sure, will do. Thanks very much for having me, guys. Hopefully see you another time.
Was that our only Glober? Did you guys do it again, or are we too late?
I think we still got Board in here. He's been pretty decent actually to talk to. I mean, I was actually Roundhound was not too bad. He's living on a refraction, dream.
He sounds like mini Ruhif.
I know. That's why I was like, is this Ruhif?
You guys just like Australian Globers? Is that what it is?
Well, those guys down there, they're upside down, so.
I mean, I find I might have a propensity for them as well, so. It's like 3 of the 6 Globers that I can tolerate are from Australia, so I don't know what happened there.
They're a little bit more calm, your average Glober.
Yeah, even Swall ain't that bad.
Yeah, I think I was thinking of him.
I mean, apparently flat earthers don't think that Australia or New Zealand exists. So, I mean, are we sure that they're even from where they say they're from?
You know, what's funny is that he said, so you don't think refraction? No one's ever said refraction doesn't exist. It's just not magic.
Yeah, but
plus you have to determine. I was just going to say, sorry, you have to determine what type of refraction, because don't they claim 4 different kinds of refraction?
Well, I think they just like to say we don't believe in refraction because it makes us sound stupid. It's convenient.
I mean,
does it me?
Hola, amigos.
Man, we got a panel in here now.
Who's up in here now?
who's that?
Yo, I heard we were talking refraction. You guys like refraction?
Oh, look who it is.
Who is this? What about
I learned
new phone?
I learned about this new thing yesterday called incoherent scattering, which causes contrast reduction, which means that things can't refract forever. There's a limit on refraction, guys. Oops.
You know, I was just hearing something about that. What was that again?
Well, the basic starting premise was, doth thou see thine earth's curvature from thou airplane, my lord?
I think
and
that.
The answer to that question was, mixed between the globularists. Some globularists said finding earth curvature is like finding Goldilocks' porridge. You have to get the altitude just right. If you're below 35,000 feet, you cannot find earth curvature. If you're 45,000 feet or above, you're most likely going to find the earth curvature. If you're 60,000 feet or above, if you're one of those pilots that's on that plane, that's on that top secret shit, if you're on that altitude grind, brother, you got nothing but curvature is what some people are alleging, right?
So,
but what was...
Well, as you said that, I was thinking of this video where they got this SR-171 pilot on there saying that he was in Tucson. He could see the Rocky Mountains from New Mexico all the way up to Canada.
Oh yeah, bro, you're looking at a hard refracted image there.
Hard
or whatever.
Well, dude,
I guess
wasn't
yeah, dude.
Incoherent
just
scattering.
An insane amount of refraction, boy.
Dude, incoherent scattering limits it to 300 miles maximum, and under the best conditions, assuming all like the best principles, right? That's what your presentation said, because I remember they used the same factors as Rayleigh's, but came out with 330 kilometers.
330 kilometers. If you had the best spot. So this calculation for the 30 for an example of an observer at sea level looking out at the ocean. It's like whatever it has cost or whatever.
You jump it up pretty bad there.
Shit.
Well,
yeah,
what is new?
Incoherent scattering.
Yeah, incoherent light scattering versus like coherent scattering, right? So it's the other side of and they showed a bunch of pictures where the contrast just gets indistinguishable, so that you actually can't tell where the horizon is, and thus you can't tell if the non-line of the horizon is bending or not with your eye. That's the premise, right? And there's an actual finite limit to it based on math, real world observations, empirical data, etc.
So that's the reason why we can't see China.
Yes, precisely. One of the very good logical reasons.
Well, that and simple atmospheric density.
I also seem to remember a passenger on an SR-71 that was allowed in the cockpit because his friend was a pilot and they were giving him a ride. And either he mentioned that they were flying overnight and could see the sun the whole way, or they could see the Terminator line from where the sun was illuminating, and that was what turned him into a flat earther. I don't remember where it was or who it was, but I seem to remember that in an interview, I think probably with Dave, I think.
Yeah,
but,
it was
that'd be something to look into.
It was him seeing the sun the whole time.
And it was
I'm gonna switch Discord accounts.
I thought it was that. Yeah.
Or whatever account these are. I'll be right back. You can drop this one down.
The Talon? Okay.
We got a mute.
Yeah, But yeah, that wasn't an SI. It was a passenger jet, 747, I believe. Yeah.
Well, that 330 kilometers on that incoherent scattering or whatever, that kind of throws a monkey wrench in the Peak Gaspard, doesn't it? Because that's only 205 miles and Peak Gaspard is 275.
Here, I just put the screenshot from the presentation that Alan did with the math in it that gives the 330 in this in this. There we go.
Yeah, didn't somebody make a joke about Compton scattering? Talking about that?
Yeah. Alan was like, "What's your favorite type of scattering?" And I had to quickly rehearse myself on Compton scattering versus incoherent versus coherent light scattering. There we go. Yeah, dude, another like math-based, logical, empirical approach that says actually, in reality, nobody sees forever. That's retarded. And there's other ways that we do that, right? Light attenuation, atmospheric opacity, Rayleigh's criterion for angular resolution, being able to optically distinguish one thing from another has a much lower limit than 330 kilometers. All those things put on stacked together, right, means of course no one can see forever.
Shout out to everybody joining the space there. Man, does anybody want to listen to Sydney right now?
Nope. I think
I
retards
know
should be
I don't.
ignored.
That's
Yeah.
why I have him blocked.
Yeah,
Yeah.
well, he came in this.
No hesitation in that note.
I have a very firm blocking retard stance. I don't know if you guys are on board or not. But...
I think I'd rather squat in a bucket of broken glass.
taking it to 2 new levels.
Yeah, and we've had enough of Sydney and his ridiculousness. So, how you doing down there, Board?
Good. Yeah, I was enjoying the discussion with y'all and the Australian fellow.
So, did you watch that video?
Yeah.
So, what do you think about Aries failure?
My first thought is that the amount that water. So, I mean, I guess context for anybody, it's a experiment to test whether the Earth is moving or the stars are moving, and by like whether or not it hits the center of a telescope, and the video's in the board or whatever, and but my first thought is just that the precision the experiment would have to have for the amount of the water slowing down the light enough for it to be noticeable. I just feel like I don't know if I like. Do we even have that precision today?
You should see the setup that they use, the giant brass tins, mechanical gear down to the micron thing that they would spin to get the actual alignment. It was aligned to the zenith mount. It was to the ceiling with great brass things that it sat in. The museum pictures are ridiculous. So yeah, we have it today, but these people were determined and definitely adept and were equipped.
Okay. Yeah, the actual telescope that he used was a big old monster one. It wasn't like this illustration. That's just
right. Yeah, it's not. I guess it's not misleading. It's just like, yeah.
It was a 3-foot telescope. It was like 30 something inches, I think.
Yep, a solid 3-footer on a pair of hinges. You could swing it on the same axis vertically 180 degrees for orientation view.
Yeah, it's just called a spirit level. What they had it on board, but you're right. It does take a lot of precision, but they also had these like
all right. Testing mic check.
Gotcha, boss.
We can hear you.
All right. I couldn't get my mic to work on my phone, so I'm back on Cat's phone. Anyway,
can you hear Piezo?
No.
Yeah, you can't hear me?
Oh, I can now.
Okay.
Oh, okay. Because you were just talking over him. I was like, no!
I was answering board. But they had these micrometer slits. Think of it like a crisscross chain link looking thing that's like really, 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 really small. And you can use that to track, motion I agree though with you. Like to think that they were able to even measure like stars with this level of precision at all, regardless of it being this experiment back in the day. Because you got to think, if they didn't have digital timing equipment, or they didn't have digital timing equipment, everything had to be done by hand. But how is this man looking up in the sky through the telescope at this star and also timing it at the same time, right? They didn't have stopwatches, or at least they didn't have stopwatches that are like precise enough. I don't know when the first stopwatch was invented. Maybe they had one in
Yeah,
1871,
that wasn't actually an issue, Pizzo.
but still, the human reaction time. Anybody who knows like sports or gaming, dude, top of the line athlete reaction time. If you're really good, you can get it between 1 and 200 milliseconds. But like most people's reaction time is like a few hundred milliseconds, and in order to detect a difference of, what was it, a 0.8 arc minutes, I think it was, in order to like measure that, right? We're talking that at the speed that the stuff moves across the sky, we're talking like 50 or 60 something milliseconds of time for that difference. So like the difference in like the angle that he's claiming to measure, which is almost nothing, is like 5 times or more smaller than human reaction time. And he's having to look through a telescope while he does it. So it doesn't have the details in the paper of how they did the timing. They just said that they did it, but I would love to have that explained to me. How you can, in the 1871, you can be measuring down to the arc second level, looking through a telescope and accurately time that.
Were the people conducting the experiment flat earthers?
No,
No.
not to my knowledge.
No, not at all.
Society in London.
Yeah, what's the opposite?
Actually, I just read Aries' private that's never before been published, and he actually.
Man, you're breaking up, but I assume you made a funny joke.
Still chopping it there. Yeah.
Super, super funny.
Yeah, it sucks.
It's always the funny ones.
Yeah.
But Board, not going into the how did they measure that, just if we grant it to them, which we kind of have to in order to even discuss it. If we grant it to them, then it doesn't make any sense in the mainstream paradigm, because theta equals arctan V over C. So there's only 2 variables, one's V and one's C. The V of Earth is not changing. Only thing you can manipulate C, they manipulated C, and the angle still didn't change. I mean, it's just like very clear cut and dry, plain and simple. And then Alan knows of that. Gosh, who are the other 2? Didn't Mickelson do one with some other guy as well, Alan, where they did the same type of experiment, but it was in a room instead of looking at a...
Gail Pearson, I think. Mickelson, Gail Pearson, I think is what you're talking about, right?
No. They had a tube with water in it.
And Mickelson.
Foucault and Mickelson, yeah. They had
okay. Sorry.
Yeah, they had a tube with water in it, and they were looking at a light through a light shining through it, and looking at the deflection that it made into the wall as they moved the apparatus, and they were able to use that same equation to correctly predict the angle of deflection of the light through the apparatus. But then when Aries applied it to Draco or whatever, it didn't work.
Unlucky, dude.
That was Alpha Draconis.
Alpha Draconis, yeah, that's right.
It's actually Gamma Draconis.
Gamma Draconis, you're right. Yeah.
I said corrected. Gamma Draconis for the point.
Oh, there's no way I corrected. That's one out of 700,426, baby. I'm coming for you, Stone.
You put that one up on the wall, bro.
Yes, sir.
But yeah, Board. So we have precedents. We have precedents for that same exact method being used to correctly use that same equation to properly predict an angle deflection.
Did we lose
you guys? Yeah, I can't hear Pizzo anymore. Oh, I'm glad it's not me.
He just dropped down to listener or something.
Yeah, we lost you, Pizzo.
Yeah, I see that we're Piezo. I see him connecting.
I don't see that.
Oh, nice.
Yeah,
So
I
the
guess
little reconnect thing. Dude, Twitter's up their game since I took a little vacay.
Not so much.
Just straight up
it's still
drop
pretty
the
dog shit.
Just imagine, Pizio was telling us his progress on how he's getting to the moon, and that shit just happened, man. That never happened to our space boys. I'm just glad 1969 happened. Shout out, NASA.
I hear Alan, but I don't see Alan. Is he up here?
Sometimes Alan is Cat,
Yeah,
and
it's Cat Boss.
sometimes
Are you
Cat is
talking about?
Alan. Yeah.
Are you talking about
The
Callan?
ghost of Alan?
Ah,
Yeah, Callan's here. What's up?
Alan?
Wait, what the fuck? What account are you on? Are you on the board again?
dude, what account
No,
isn't he on?
I'm on Cat's account.
Oh shit, what the fuck? I thought Cat was a separate person.
You'd
He's a
think
separate
that.
person. I'm at her
No,
house.
you'd think that, but no.
I am a separate person.
Yeah, we have to both speak at the same time to prove we're not the same person.
I
On
would not-
three, we're gonna have
No, 5, 7.
what?
Hello.
How unimaginative. All right, I believe you.
Dude, how good at ventriloquism have I
Dude, I
gotten,
was
boys?
just about to say, man, I think you're a ventriloquist, man. I can't trust this.
Dude, I worked all week to perfect that act, and that's as far as I can take it. That was sick. Got you guys.
Good, man. I'd buy tickets to it. But what's even funnier, you're talking about how they figure out the timing mechanism stuff. It was 1871 where they built this fancy ass telescope, and then back in 1887, a little ways down the road there, they built this interferometer that was 10 times more sensitive than it needed to be to detect motion. And they haven't even built the freaking power tool yet. I mean, we're caring about the stars and the motion of the Earth way too much. We got guys out there hammering and chiseling their brains out, man. Come on.
Well, that's because the context is they were looking so hard for the Earth's orbital velocity that everybody knew was there, but nobody could find or measure in any way. So they were like, all right, we're going to make the badass tools that we can. And that's why it's called Aries failure. Because, dude, like, you know.
Like, okay, when we look through a water filled with telescope and we know the angles have changed and it doesn't, like, that's fine. We can chalk it up. You know, the light already comes in at that angle, so who cares? But suppose we split a light beam of a known wavelength and have it complete a circuit that's orthogonal to itself. What do you think would happen then?
Well,
yeah, no, I think what's important, another Einstein quote that's important is if you fail a problem 99 times, at least you know 99 ways not to do it. And I mean, that's what
No,
they did.
that was Edison. That was Edison and the light bulb.
That's so Edison, dude.
Oh, it was?
Can y'all hear me? Is it working?
There you are.
Yeah, welcome back, Kiza.
Sheesh.
Sorry, real quick, that was Jack Black. But anyway.
Sorry.
Yeah, so the light hitting the center is what they said, or what a lot of people claim to confirm that the stars were the ones moving and that the Earth was stationary, right? It's that the light still hit the center of the telescope?
When the water was filled, yes.
Right. And so then what Einstein came and had to do, as you say, is prove that there was a reason that was still happening, even though he like on the globe.
No, Einstein came after Michelson Morley, where they did not detect the orbit of the Earth around the sun.
Right.
Well,
and
to be clear, real quick though, the relativistic framework is the same framework as Lorentz's framework. So if you ever heard like a Lorentz's ether theory, it's the same exact mathematical framework. And they did propose that as an explanation to why there was no change, because what they would assume in the Lorentz ether framework is that the light ray is already coming in at an angle, and you can transform between a frame from the sun and versus a frame from the Earth, and you would see the angle difference from the other location if you're a stationary observer on that reference frame. But you know, you can't see it in ours or whatever. So they did actually go with that explanation, but it was just under
speed it up.
It was just under an ether framework as well.
Yeah, you'd have to make the angle smaller though, and make the speed of light faster, or have it be in order to keep it slower. You'd have to have it carry the light in the opposite direction of the motion of the object, which makes no physical sense. It's retarded.
Right. Well,
it's
that's if you don't do a Lorentz transform though.
Well, it seems pretty straightforward to me that if the light enters Earth's gravity, that it would also be affected enough to still hit the center. Because
no, light doesn't get carried sideways, bro. Light's not being carried sideways.
Then how does light go into black holes?
Okay, bro. Here's that has nothing to do with
This
water.
light goes
We're talking
through
about
black holes.
water in a telescope.
Right.
Yeah, we're talking about water in a telescope. So when you put water in a telescope, the light slows down. So what's actually causing the effect? Think about this. There's say there's no water. If this telescope is flying through space like 60,000 miles an hour, right? Okay. When the light enters the far end of the telescope, which is moving, it takes a certain amount of time to reach the bottom, the other end. During the time that it goes through the telescope, the telescope will have moved horizontally out from under the light, and it will not hit in the center. It will hit slightly off to the side. So that's why you tilt it in order to make it hit in the center. Once you put water in it, though, since the light is moving slower now, it will take longer to reach the bottom, which means the telescope that's moving 60,000 miles an hour sideways will have more time to move out from under it. And since it has more time to move out from under it, it moves out from under it further, which means it is further off center, meaning you should have to tilt it even more to center it. That's the whole premise, and it makes perfect physical sense. It actually is just based on that same equation, and yet it didn't happen. It took the same angle even when being slowed down in water.
Right, because it's under effect of the Earth's gravity.
That doesn't make what you're saying doesn't comport with what I just portrayed to you. It's like saying, yeah, because there was fairies and they sprayed pixie dust, it just makes sense. You're not actually
Well,
giving any
no,
mechanism as how that makes sense. You're just saying the word it works.
There's like hundreds of millions of people on the planet who like use those equations every day to like build important shit, like these phones and computers run. Like
V
I
over
know,
tangent theta equals V over C is used to build our phones.
is that a gravity equation?
No, bro. It is
The only
the
equation.
used to predict the, it's the only equation at all that's used. And it's the equation for stellar aberration. They say that the reason that we have stellar aberration at all is what I just described to you. The telescope's moving sideways while the light's
Who's they?
traveling vertically.
Who's that?
Astronomers since 1727. So James Bradley invented stellar aberration as a concept. But anyways, because the light's moving vertically, you just imagine, the stars above you, right? So the light's moving down vertically. You and the telescope are moving horizontally. Those are two different speeds. So you take the ratio of those two velocities and you do trig. You make a triangle out of it. And you say tangent theta equals Earth speed over light speed. And that will give you the angle that you have to tilt your telescope to center the light. If you change the light speed, it should change the angle because there's literally only two variables: Earth speed, which you cannot change, and light speed, which you are slowing down with water. When you slow the light down in the water, the angle will be different. Because now if it was V over C before and now it's V over 75% C now, it can't. Those two things do not equal the same number. The angle will be a different number.
But you just don't believe. You're just assuming gravity's not real.
Well, dude, that has nothing to do with this.
Gravity is
You're just
not,
saying words
it's
that
not
don't
the
mean
explanation
stuff right
for
now.
Aries
No,
failure.
I'm
bro.
saying the same word every time, and you just don't think it's real, and that's okay. We just disagree whether or not gravity's real because that's
No, what he's talking about has nothing to do with gravity.
Zero, yeah.
right. No, you don't think it has anything to do with gravity because you don't think gravity's real.
Nobody
Oh.
in any community of physics appeals to gravity whatsoever as having anything to do with this at all. It's about relative motion and the comparative velocity between the two objects that are said to be moving in relation to each other.
Not only that, but I literally, it may be anecdotal evidence, and I'm believing my wife in this, but literally, Physics 101 says that gravity is not a factor, that you do not factor gravity in any of their calculations.
No, we don't use gravity at all when we do equations with light.
Wait, you're a flat earther and your wife's a physicist?
Regardless of what that twit Eddington said.
I didn't say that. I said that Physics 101 in college says that gravity is not a factor in any of the calculations.
That's
so
like so
in other words,
true. Has
So
anyone
no,
else here taken a
then
physics
why
class?
would the very first physics class that you ever take at a college level say that it's not a factor?
You actually do it in physics too, but either way, she's still correct. Nothing that we do with light has to factor in gravity, at least not on Earth. Maybe if you were doing some theoretical math with black holes out in space, but that's not what's happening here, so it's irrelevant. Still, once again, completely relevant.
I don't get how you're trying to say that theory of relativity and this experiment have nothing to do with gravity.
Bro.
Well,
can you explain why it does have something to do with it? Can you explain why that would cause the water to not affect?
That was how we got here. That's how it started. The experiment was proposed as something that, so the trajectory was sort of that a lot of scientists were like figuring out how the Earth was moving and whatnot. And then this came up and it was like, wait, well, that's not what we expected. And so then, as Nick Cage said, Einstein had to come up with the theory of relativity, quote unquote. I mean, like, he didn't have to, it's just something he discovered, but it reconciled this experiment with the heliocentric worldview.
So, real quick, there's an equation. I don't know how much math you know. Did you do like high school math? Did you do like trigonometry
Just
or
Calc
geometry?
1.
Okay. So you know what tangent is?
Right.
Opposite over adjacent in a triangle. There is only one equation, period, that is used for stellar aberration. It is tangent theta equals v of Earth over c of light. Okay? Velocity of Earth over velocity of light, v over c. I'm gonna say v over c from now on, but you know that v is representing Earth, okay? Tangent theta equals v over c. There is no other equation, and there are no other variables. When you say, well, what about gravity? There is no variable for gravity in that equation because it is a non-factor. The same equation is used to predict everyday normal stellar aberration with air telescopes. So when we use a water telescope, it should use the same equation, but yet it didn't work.
Right.
So you have to use the math, and when you use the math, the only variable that you have any hopes of manipulating is the speed of light by slowing it down. And when you do that, you do not get the predicted result. That's why it was called Aries failure, because he failed to get the predicted result.
Right.
Okay, so gravity is not a factor in this situation.
Yeah, I just don't. I guess I either I either disagree or I don't correctly understand the experiment.
Someone link him Malcolm Bowden's little video.
There's 3 or 4 up in the nest. There's the stats. There's the actual aberration comparison between seasons. There's Stone's analysis that I popped up there, which goes through all the data points, the tools, the equipment, the process, even accomplishments of George Airy himself. And then there's the actual Malcolm video that someone else put up there. So everything's up there.
Yeah, if you want to take 3 minutes to go watch that, it's like a 6-minute video, but the first 3 minutes gives you the illustration, it gives you the visual, allows you to visualize it and see it, and it makes perfect sense. Take like a break for like 3 minutes and go watch that, bro.
The what is it in the jumbotron? Or
did you put it in the jumbotron chain?
Yeah. So I can't scroll. Let me see which space it's in. Is it working for everybody else?
I mean, it might even have been similar or same to TN's. Sorry, Stone. Are you talking? I don't know that I can hear you.
I was just about to. My purple pill function is so busted and has been for months. I can only see the final 2 posted items in that list.
All right, that's exactly where I'm at. I can only see the last things I posted.
It's so fucked up. I mean, I want to slap Elon in his little pee-pee face, man. Just like, oh my god, some fucking idiot needs to spend 10 minutes and fix this thing. You know what I mean? It's ridiculous. I can't be the only one.
I just tagged you, Board. I just put it in the space chat and tagged you, so you can just go see your notifications and watch it.
Thanks.
Good enough. Thanks, man.
But yeah, the progression of experiments from there is funny and progressively more desperate, right? Michelson, Morley. And then they were like, okay, it's definitely going to be here. We'll invent an instrument specifically designed to cater to the sensitivity we need. Boom. Well, we got, 30 kilometers. We need 30 kilometers a second. We got 6. Didn't get 0, but we got some motion. We don't know what that motion is. We'll have to do more experiments. And like, okay, what we got to do is invent the framework in which we interpret that, and we'll retroactively reduce that 6 to 0, and we'll say, actually, it was a no result, and there's no need to redefine all the physics by coming up with relativity and trashing Newtonian mechanics, right?
Well, yeah, and then they had Gail Pearson after that, and then they're just like, oh wait, we're spinning, but we're not orbiting. Wait, that doesn't make any sense. Hang on. Ah!
Yeah, and then we had to have our boy Wang come along in 2011 to linearize the Sagnac effect, because they were like, actually.
Sorry, go ahead.
I think my mic was messing up. It's all right, dude.
No, I was just saying it's 04. Continue.
Oh, yeah, right. That's it, 11, 2004. So, yeah, 2004, then he linearized the effect so that it was actually observed to be not an effective rotational system, but actually could detect the motion. So, the tools that they used originally were more than sufficient, and there is no Earth's orbital velocity never been detected. So, that's pretty much how mainstream fudged it on the side. All that retroactive relearning, like, here's what they actually wanted, in the words of somebody else who wasn't there. Are you eating loudly?
Hey, Pizzo, I don't want to eat
My
along
bad,
with
my
you.
bad.
Can you
I
mic
just
up there,
realized.
buddy?
Yeah,
Jesus.
my bad. The freaking Twitter mic sensitivity is like not adjustable. It just captures everything.
It's not Discord, dude. So yeah, motion's an issue for anyone who believes in the globe.
Dude, did you guys hear about that glass of water that debunked relativity theory?
Was it sparkling water? Spring water?
No, it was just regular water from the old tap, bro.
Was it in a
So
bucket?
check this out. No,
Was it that bottle? Was it that glass of water in the Chinese space station?
No, different woman with a glass
Equally
of water.
entertaining.
But equally as entertaining. So check this out, lads. For relativity theory, they predict that the speed of light is reference frame independent and it always travels at sea no matter what. And so when they get into the Aries failure thing, which Pedro was just talking about, the relativistic answer for them, the way that they account for water, the way that they account for light and water, is to not include the refraction index because they don't care, dude. They're on that IDGAF lifestyle. So they actually predict no timing change in water for light. Now, obviously, there's the change because we can see refraction, we can see what that looks like, we can see the physical effects of that timing difference. But check this out. Like a year or two ago, this woman on YouTube, her channel is called Through the Looking Glass or Looking Glass Universe, something like that. She was a former quantum mechanics PhD teacher. And what she did was she had this idea that she was going to test the speed of light in air versus water to see if it was truly a constant in the way that she's conceptualized it her whole life and has been taught academically. And so she took this beaker filled with air, just nothing in it. She uses a laser meter and she measures the length of the cup, and it comes out to be like 14 centimeters or something, or like 10 centimeters, something like that, right? And then so she adds water to it, and she does the same thing again and shines the laser meter down to the bottom of the cup filled with water. And this time, because of the timing difference, it reads the distance as 14 centimeters, which correctly is the amount that light would have been slowed down to give it the extra time in real seconds or whatever. So she showed that for, in the lab frame, the inertial observer who's supposed to read the speed of light as a constant is measuring the speed of light being different because it's deriving a different distance. It should be the same. So the whole thing is like, there's a real timing difference, and so you can't do like a transformation out of an Aries failure experiment to answer it, because either way you look at it, there's a real timing difference. Now, however they want to conceptualize that, now sometimes they'll say like, oh well, the water is just taking a path length change, but it's still traveling. I mean, the light's taking a path length change, but it's still traveling at the speed of light. It doesn't matter. However they want to try and like rectify it on the back end. In reality, there's a real world timing difference, and that, that's all that matters. So anyway.
I thought they already pretty much did that, and they're just like, oh, well, it's bouncing around in the different molecules, which is why it took longer.
Yeah, so they can like say that when there's no consequences or stakes on the line, for fun, they can say that. But they still have to rectify the real timing difference because it's not predicted in their equation. So they actually can't like transform out of Aries failure. And they've known this for a long time, but
Who was up next? Sheep?
I think my boy Sheepdog was.
Nah, it was either Sheep or RG. I thought it was RG, but maybe it was Sheep.
It's all good, man. That's so weird seeing Alan talk on a different
account. Alan.
I'm like, where's Alan's profile? I don't see his profile.
Are you talking about Alan?
Anyway.
Hey, what's up, guys? Sorry about that. Every time I don't interact with my phone for a minute, my screen locks. So my apologies. Yeah, I'm glad to see everyone's doing the Flat Earth Friday, man. Good to see everybody. Haven't been on here a while. I've been trying to focus on the YouTube side of my thing, trying to build a website and all that good stuff. It can be a headache sometimes, but yeah, man. I looked at the title here. That's what kind of piqued my interest. Where is the sun, moon, and stars? Cool topic, man, and I really like the way that was just broke down with the light and the medium change and the wavelength kind of speed difference and provable with the I guess you would call it a propagation.
Hey, Vaughn, you're hot like.
Yeah, time to mute up there, Vaughn.
Sorry, guys. That was my son. He grabbed my phone.
I thought it was a sound effect. That's so funny. I'm glad. Good to see you interacting with your kids, man. That's awesome. Hey, so yeah, sun, moon, and stars. I won't take too long, but my guess or my best hypothesis, I would say, just being able to observe some of these things in cameras and up close, in focus camera work. I think the similarity is they all have this very thin outside shell border that's observable, telling me, I guess, in my limited knowledge, that these are projections. These are being projected up, I would say up on something or down on something. And hopefully nobody hates me for saying that, but the medium change, either that's the ether we're seeing with these different color flashing things, and we're just seeing the effects through the ether with different, different frequencies. But I do also notice that these stars seem to have a center shell looking circle, but the symmetry and the geometry is just beautiful. And I don't know where they are, but they seem to be coming from somewhere, is my thoughts. Thank you.
Right on, dude. Yeah. What I was gonna say before that was Felix Baumgartner died. I don't know if y'all heard that.
Didn't he have a heart attack while paragliding over the ocean or something?
I don't know if he had a heart attack. He had a paragliding accident. See the whole
Yeah,
thing.
I think he
Yeah,
died
he
in the
missed
air.
the pool. If only he had hit the pool, that would have been a serious
Did he-
ass drinking story. You know what I'm saying?
Ooh,
So this
did he hit
dude
the
was
So he
ground?
had a heart attack. I wonder if he was vaccinated.
Yeah, he hit the ground next to a pool at a hotel.
so he was
Shit, man, that's sad.
paragliding and had a heart attack.
Yeah, I think I read that somewhere.
That's
Unless,
bad.
unless I just manifested it and made it up.
It's just more fucking mainstream shit. I mean, the guy was totally healthy, obviously. He was in his 30s, wasn't he? There's no way the guy had a fucking heart
I think he was in
attack.
his 50s.
It's ridiculous.
He does that like
So he was
wear a parachute
56.
and then you put like a
Oh,
fan
I
behind
said
you.
corrected. Yeah, he
Yeah, I
was.
think
He
he's the
was about
first
56.
50-year-old to have a heart attack.
Yeah. No,
Yeah,
you're
you
right.
would
He
think
was
that guy had
56.
nerves of steel, right? Like nothing would shake that guy after all them jumps.
Well, I know that when he did the Red Bull jump and the Earth didn't rotate beneath him, right? When he was in the air for 4 minutes and 19 seconds with the usual rotation speed of 1,600, something like that, kilometers an hour. Convert that to minutes, he should have been
Yeah.
like, what, 38,000 from 38,000 meters or 127,000 feet. It would have been rotated out, like, I don't know, a huge amount, 120 kilometers, except he landed right, almost right where he left. So that's what I remember about Felix Baumgartner. Now that he's dead, that'll be his great accomplishment.
I'm not seeing heart attack, but it's saying that he lost control, then had a medical emergency, and then crashed a few yards from a pool.
Yeah, I heard the thing. If I remember, said that he was dead before he hit the ground. So whatever happened to him happened in the air.
Yeah, not only that, but he landed the wrong way. He landed west of where he took off instead of east of where he took off.
Oh, and the actual Red Bull jump. Yeah, there's a lot of good things about that.
Yeah,
He landed east of where he took off instead of west. That was the deal.
Right.
Yeah, I got the figures here actually because I did a video on this. He was in the air for 158 minutes going up. And then he dropped for 9 minutes straight down. And instead of what the rotational math is, when you go up for 158 miles and you get to 24 miles by the time that you're done, all the trig on that, he should have been, his GP should have been 6.36 miles to the west of the airport, runway 17 where they took off. But no, he, let me get the figure right. Where's the figure? It's actually 43.77 miles to the east is where he actually landed.
That's awesome.
He outran the Earth's spin in a balloon with no propulsion whatsoever. Yeah, that's always a good one for the Globies to try to explain.
Hey, Stone, do you happen to have any recollection if there was any like recorded weather data that day, like where he took off from, or because I'm sure they would try to find a very low wind area, right?
Well, I got two things to say on that. Exactly, very low wind. That would be the first thing. Is that in order for him to take off in that balloon, the way they did it with the crane and filling up the thing with helium before and letting that go first, there has to be absolutely zero wind in order for him to safely take off and not be dragged across the ground and shit with wind when he's trying to get some air. The other thing is that I think Kevin Bowe spent some time on this looking for weather reports, but we could only really find something this far after the fact from a station or a beacon that was recording stuff about 100 miles to the south. So it's not really the same. And it did show some faster wind speeds up, but higher than where he was for most of the time. So it's not really something that was going to influence his position. And you got to consider here that we're talking about 24 miles straight up. That wind is only really a thing for the first maybe fifth of that voyage. After that, there's just no atmosphere anymore. That's why he was wearing the suit. That's why he was approaching the Kármán line. Although that's a 62 miles and he was at 24. It's the way you look at the entirely logarithmic drop off of atmospheric pressure over that altitude change. You can understand why he was wearing one just to be safe. But yeah, that's how I would plan that.
Right. And yeah, I was thinking just as you were talking, like they would probably have to do months of planning and make sure, make sure everything was going to be as how do you say, kosher, as Jewish as possible. I'm joking.
Well,
Anyway.
you got to make sure Johnny's not going to go splat. I think is the main focus of all the preparation.
That's
I wonder if there's some kind of release of helium as it, or some kind of control with him stopping at a certain point, or if they just ran into thicker atmosphere and he couldn't go higher, maybe, or
No,
you know what I mean,
don't.
or they were.
It's
Go ahead.
physically antithetical to run into thicker atmosphere. He's going up.
Okay.
I've got
Right.
a
Yeah. Well,
I've got
you
a
know,
question
I
on
guess you
the
know what I mean, like the
atmosphere.
balloon. Go ahead.
What's that, Ken?
I got a question on the atmosphere, and I only caught it because somebody posted something that showed data from a high altitude balloon. Now Felix Baumgartner, he would have been about 124,000 feet or something like that.
Yeah, he got up to almost 127 by the time he stepped off.
Okay, well, one thing I noticed, and I even went and started looking into AI, because they talk about, you get up there at 115,000 feet. This thing was registering pressure of 0.09 psi on the little thing. But I noticed that it was talking about airspeed, and it had airspeed of like 54 miles an hour. And I'm thinking, well, this is a balloon. It's not a plane. It's not in flight. So I just went to AI and asked it, what are the wind speeds at 115,000 feet? And it said that the wind speeds are roughly 45 to 100 miles per hour. And so I thought, well, if there's no air, how are you having wind speeds? So I asked it how what was the I think I used a cubic meter, and I asked it, how many particles in a cubic meter at sea level versus a cubic meter at 115,000 feet, and it gave me a number for sea level at like 2.3 times 10 to the 25th at sea level, and it gave me 9.6 something times 10 to the 21st at 115,000 feet.
So 1/10,000th of the value.
1/10,000.
Would that be something like solar wind, like a plasma pulsing from the frequency, sun frequency, maybe?
Sorry there, G, but to help Ken out, that if you have an exponential difference of 5, like one's 29 and one's 24, then you have a difference of factor there of 10,000.
Well, it was 4. It's 25 and 21.
Okay, so it's 4.
10 to the 25th at sea level, and 10 to the 21st at 115,000 feet.
Okay, to get that clear, can you see it again? Is that 10 to the 24th and then 10 to the 21st? Is that what you said?
Yes.
Then it's 1,000 to 1. So it's 1/10 of 1% of the pressure.
Well, I understand pressure, but I was talking about number of particles. I mean,
That's what it equates to.
Wind.
When you go across the ideal gas law and PVR, blah blah blah, that'd be temperature, pressure. Yeah, that's how that translates.
So closer to the sun in altitude, like height, would produce, still produce, right? Though, like that kind of pressure. It's not pushing against like particles per se. It would just be producing a plasma particle itself. Or
no, we're just talking about lack of pressure, lack of matter per cubic volume. You know what I mean?
In
That's
height.
how you at altitude.
As height.
Yes.
Okay.
Yeah. Gotcha. So that's and what he's relating to is what is
I'm
the
just
effect
wondering
of
where
wind going to have, right? The point is, like, picture yourself at the beach with a pinwheel. You blow on it, it's 6 inches from your face. You blow, it spins, it does about 180 RPM, right? Okay, great. So we instantly transport you with your pinwheel straight up 24 miles.
Mhm.
Okay. And you try to blow at the pinwheel. How fast is it going to spin? The point is not very fucking fast. So even though allegedly the quote wind at that altitude is going really fast, the point is there's not much of it to actually physically push on an object with per cubic meter. So the effective wind
I get it.
is a tenth of 1% of what the effective wind is at sea level, is what we're driving at here. Did I get that right, Ken?
Yeah, you got that right.
So the idea is that the Earth's supposed to be moving under this balloon.
Precisely. That there's
Well,
a rotational there. That the Earth is doing 660 miles an hour according to Globy math at that
Right.
airport, at
Right.
the surface. And
But
as you
that's
go
not
up
what.
in altitude, hey Board, as you go up in altitude, your R increases as the spinning body, right? So that means you, without any additional forward vector force, you mean you're just floating straight up, the rotational, you should catch, you should lose ground on the Earth that's spinning below you faster,
Right. But
angularly
that's why
speaking.
flights
That's
from the
why I
East Coast
suggested
to
that
the
you would
West
be
Coast
6
don't.
1/3 miles to the west when you drop back down, if that's actually what was going on with still air.
Right. That's why flights from the West Coast to the East Coast aren't faster. And that's why then vice versa, because the atmosphere is moving with the Earth. I don't think globies or flat earthers disagree on that.
Actually,
I think
you're very
in the globe model, it's big at that height. It's the atmosphere is being pulled, not pushed, right? So, if what Ken's implying or what he's found out about, there's something still moving up that high. Is something being like a force producing this movement, like that we can measure, or is something being pulled? Like I think that's the next question, right? Would be logical.
There are bigger questions when it comes to air mass movement velocities, and that is terracing.
Okay.
Okay, so like the globies are having a really hard time here explaining how it is that, say, at 25,000 feet, say, over a given portion of land, the air is going to the east at 125 miles an hour, yet 10, 15,000 feet above that, the air is going to the west at 125 miles an hour. Now you see, there's no way to argue laminar
What?
friction.
Have you ever seen like a
That
bunch of
happens all
dye
the
poured into a
time.
bowl? Have you seen it like go in a bunch of different directions? I feel like that's super easy to understand.
Yeah, but that, you see, that's a fluid, not a decreasing pressure altitude. You know what I mean? That's a totally different strata.
No,
It's a totally different coefficient when it comes to the laminar friction on the bottom side of that. It's absolutely apples to oranges. Okay.
it's really not. Like
It,
it's
it
it's a
absolutely is. You've
gas
got,
in an
it's in
open
a
space.
freaking container, man. It's got an outside edge to it. Of course it's different. It's
Well, yeah,
the
because
Yeah, and have
geometry
you
is
ever seen the jet
inverted.
stream?
I mean, like you could have a
Whoever the
puddle of
globe.
water on the ground and you could put dye in it. It's the same
The
thing.
densities are
Can I?
totally non-similar. Like, I don't know why you went there, man. It's just crazy.
Because everyone has seen dye go into a like bowl of water and seen it move in a bunch of directions. Everyone knows that if you're like trying to play golf at any
Yeah, that's
moment, the
water.
wind
How
could be
much
going
how much
different
dye
directions.
and water do you see at 100,000 feet? How much is there a lot of dye and water up there, man? I don't see any.
Oh, you got me. Sorry,
Where are you
I
seeing it?
forgot I was trying to explain that there's 10 gallons of dye in every square foot of the air. No, I'm just trying to
Cubic
explain
foot,
how it makes
but you're
perfect
getting
sense
there.
that air could be going in different directions, especially 100,000 feet away. Like,
No,
like
10,
you said, I'm
15,000
weird for
feet
trying to
above.
point that. Is,
Same
how are you
point
trying
over
to
the land.
counterpoint that?
It's the same point over the land, 10, 15,000 feet above. It's going 125 miles an hour, 180
Right.
opposite
Yeah,
degrees.
it's not like the air is like all on one team. Like it's just a bunch of different particles in a space. That's not even something flat earthers disagree with.
We're talking totally different densities of air at this point as well.
Well,
This
okay,
is the
even
hard
more
part,
reason for
right?
them to be going different directions.
What's going to cause it to go in the direction in the first place?
Brownian motion. It's just random. Stuff's not gonna just sit there.
It's just random, dude.
No, I mean,
It's
like, have
okay,
you ever
dude.
poured out a bucket of marbles? You think they're all gonna just land in the same spot and sit still?
Are
Like,
you familiar with the term jet stream? It's not random.
Right. Yes.
That's what I was
Yes.
trying to
No.
get at
Right.
with
Right.
the
Okay.
globe
Okay, the
versus
jet stream is
the globe
cycling.
versus a flat.
RG, let him finish the conversation. Please.
Seriously, the jet stream
Yeah,
is cyclic
I thought they
and
wanted. Okay.
has very specific geographic boundaries to it. You know what I mean? You're really not making any headroom here, man. This is why I pointed it out. But thanks for playing. It's been fun.
Isn't that how they fly balloons anyway? They take it up to one altitude, and it's going to go west. And when they want to bring it back, they'll change altitude, and it'll come back east because there's winds up there going the opposite direction.
Absolutely, over the same point of land. You got it.
Okay, wait.
It's what air traffic control does for all the interocean over the over the Atlantic.
Wait,
over
isn't
the
that what I
Pacific.
was saying though?
No, they direct the planes so that they get proper tailwinds based on which direction it's going at whatever altitude. They create corridors and take advantage of that for fuel reasons.
Okay, then I'm
Right?
confused because I thought that's exactly what I was saying.
No, your globe
No,
needs the
the
air
point is
to
that you
all
can't
move
explain
with
it.
the Earth.
You can't
No.
explain how.
Wait, what about jet fuel?
No.
What about jet fuel?
That's like saying if
Inconsequential
you're
point.
in a car going forward that you can't like throw something into the back seat.
Oh my God, we're totally not talking about the same thing.
He jumped off the
he's
situation.
just saying random
You're talking
shit.
about the inertia of physical objects. I'm not talking about that at all.
Yeah, you're talking about the gas on the Earth, known as the atmosphere. You think if the world is a globe, it all has to be going the same direction all the time.
I'm saying that it wouldn't actually affect it at all. That there's
That's
no
not what he
such
said.
thing. There's no such thing as a laminar influence on air that's tens of thousands of feet above the land, regardless of the contour of the land, regardless of the velocity of the land relative to the air. There is absolutely no laminar friction coefficient there to
Right.
measure
No, I don't
at that
think
kind of
anyone thinks
distance.
that.
Hey, Stone, can I steel man you real quick? Maybe he's not hearing you, dude. Like when you get up to a certain altitude, there's just not enough air to even push you in a direction. So as you're up there, you're going to be going a certain speed, and the
Right,
Earth
but
is
it's
going
not
to be
21
moving
miles.
a different speed because it has a smaller radius value underneath you.
Yeah,
So
when you
it's
hit
gonna move
space,
quicker
you're
underneath
not
you.
in the atmosphere. I feel like that's pretty straightforward. But when you're 21 miles in the air, you're not in space.
Nobody's
No,
saying
but
you are.
you have a longer radius value to account for when it comes to maintaining the speed of the Earth underneath you. So you need to be going faster than what the Earth is underneath you.
The Kármán line is at 63 miles.
Allegedly.
I don't think you're grasping that. Is really, and neither does Stone. We just don't think you're grasping that part.
So
I mean,
you
you
think
invoke the
that
flights, right? You invoke the air flight, that the air remains constant, and that's why there's no difference in time. But now you want to say that the air isn't constant, that it's not moving in lockstep with the Earth.
okay, so it was at 24 miles. That's what we said. The balloon.
Yeah, about 124,000 feet or something like that.
And so you guys are saying that there's not enough air up there to be moving it.
There's air moving. There's the same airspeed. The wind speed up there is not going to move you as fast as the same wind speed at sea level because there's more particles pushing on you, so you'll feel that force. A 50-mile-an-hour wind at sea level is not going to be the same as a 50-mile-an-hour wind at 115, 120,000 feet.
Or even the jet stream that's at 7 miles or 6.5 miles. That is not going to be anywhere near. That's going to be a completely different coefficient compared to what's up there at 24 miles or 21 miles, whatever you said it was.
So because the balloon went 40 miles east, how do you guys think it went? Like, what do you guys think caused it?
It went in the wrong direction.
Right, but what do you think caused it to go east?
Well, that's what I'm putting to you. How is it that he went
Yeah,
east?
I know, but you guys can...
That's my question to the Globies. That he should have gone west. How did he go? He should have gone 6 1/3
I know,
miles
but if you're
to
saying
the
there's not
west.
enough air to influence him versus what the Globies say
No,
should...
we're not saying it won't influence. What I said is that at sea level, there's far more air particles. There's far more particles per cubic meter.
Okay, yeah.
Than there is at 120,000 feet. So a wind speed of 50 miles an hour at sea level is going to blow on you really hard. But at 120,000 feet, there's not enough particles hitting you to make you go that fast. It's going to be less force, not no force, less force. That's all.
Right. Okay.
So on a stationary Earth,
right?
On a stationary flat Earth, with that wind blowing, he can go east easily. But on a rotating Earth where you need him to basically stay with the Earth, he has to outrun the Earth spin in order to go east. So it's easy to explain on a flat Earth, a stationary Earth. A lot more difficult to explain on a rotating globe.
Board, I may have an answer. I don't know if you'll agree with it or like it, but the different density layers of the gradient of gases, right? Once you get up so high, those gas particles are a lot, smaller and less, and like they said, less amount,
they're
I
the
guess.
same
So
size, but yeah, I get what you're saying.
yeah, so they wouldn't be able to push on a physical object like a heavy balloon and that kind of weight the same as it would lower where it's thicker and heavier.
Right. Yeah.
Maybe
the
that
number
helped.
I'm getting is 18. That's just what the Google AI overview, which is super nice because you can just ask it shit. But
I
it's
mean,
saying 18 times less
we're
dense.
never going to have a perfect answer for everything. So if we argue like these small details, it's going to create bigger divides and problems with our understandings to help each other.
Right. Yeah. No, I can agree with that.
Well, we don't need to make an argument for anything. We're just observing reality for the most part. Now, like some people are taking advances and trying to figure things out, and it's a very difficult process, and I respect them for that. But the problem and the fact is that the globe has a lot of holes, and we're pointing those out.
Right.
What they thought was working in their story really isn't. It's just falling apart.
Yeah, and that was pretty much Aries' failure. I mean, that's what,
That's a long time ago. Hey, we're in the new age, brother, and we got some pretty cool technologies, and I think it's admirable to try to chase the truth, and I don't think anyone here is intentionally trying to lie about things.
Right.
Pretty honest people. I've heard a lot of talks from a lot of these guys, and I'm just now jumping back in and on X, but yeah, man, they're pretty good people here.
Yeah, no, this is probably a good point for me to leave because I'm trying to catch the Dodger game, but this has been a lot of fun. You guys are really chill.
Dodgers suck.
Well,
Good
right
luck,
on,
brother.
man.
Hey, chase for that truth, man.
Yeah, hell yeah. You guys too. I'll catch you. I'll hop in if you guys do this a lot.
Every Friday.
Hell yeah.
Hey, I heard something about jet fuel. What happened with jet fuel?
You said jet fuel. You really want to talk about it, so talk about it.
What's
I
up?
No,
mentioned it.
I think
I'm
he is no
guilty.
Stone. I think Stone mentioned that a tailwind would help
I
save
did.
on jet fuel.
That is it. Yes,
And
that's
I
as
had to
far as I
fuck with
went.
Stone and Nick Cage.
No. Just
Hey,
the tailwind
just
part,
for
less gas.
future reference. Yeah, just for future reference, Mac Miller, Jet Fuel is a great song.
I was hoping India would show up tonight.
You know what's
Who
crazy?
was it? Shane was talking to him earlier.
I seen him in the timeline a little bit. He retweeted space. But it's weird that these passenger airplanes can go over Mach speeds and never break the sound barrier and never get that sonic boom, boom. 1,200 miles an hour sometimes. It's crazy.
Hey, I've seen some weird things in the sky. I got some videos, dude, and it's this guy's using a very low light, kind of a more open shutter. I don't know the exact details, but I'll post one here, and if you guys want, his name is Scanner Guy, but I mean the things where I'm seeing from his stuff is very questionable about like how the fuck what's really going on up there, but maybe y'all can add to it. But I heard something about don't crucify me for this, but I did hear something about these corridors, these sideway corridors, like he mentioned a minute ago. And these jet, you know how these jet engines spin in opposite directions, and they're creating some kind of bubble, it looks like. And I think that's the whole jet fuel hoax thing. Is like they don't really need it. Like, you know, I think they're just locking into the atmosphere, or not magnet. Damn it. Y'all know what I'm talking about. Where these things are.
A bumblebee.
What's that? Yeah, like a bumblebee. But yeah, with these engines, these things are pretty sophisticated. What they create, let's say, is very sophisticated.
Yeah, is it a long exposure, or do you mean like literally he opens up the aperture so that he gets more light into the lens?
Yeah, he does it at night, so he can catch the what looks like to me the just the glow of whatever these things are creating, this bubble. But they seem to be super high up in the atmosphere, maybe around the Karman line or a little bit higher, but definitely
Well,
low
it
Earth
seems
orbit.
like people are asking questions, man. So definitely post it so that
I'm gonna go
way.
get one and I'll post it here so y'all can look at it.
Because I don't think you understood what aperture was.
Kind of like the pupil in a way. I guess you could look at it.
Yeah, that's what he was asking. He was asking if it was like an open aperture, like the pupil dilated, or was it a narrow aperture?
Yeah, I think it's dilated, but he does
No,
different.
I said long exposure.
I don't know. I'm gonna let y'all look at it. Yeah, he talks about it more in his videos, so I just don't have time to learn everything. But I'll put one in here.
If it's low light, then you leave the aperture open longer so that you can collect more light.
Exactly. Yeah. And whatever heat these things are putting off, maybe is what it's catching.
Yeah, that would be long exposure.
So same difference, same thing that I was saying. Okay, my bad.
I'll be right back. So if y'all ask, I'll be right back.
Shout out to everybody tuning in. Got any globies down there? Retweet the space. Got a packed house. Can't be all flat earthers down there. You think they're all flat earthers? Gotta have some globies down there.
Yeah, they're all flat earthers. They just don't know it yet.
Well, they are all flat earthers. You're right. They just don't know it. See a lot of guys in the timeline. I ain't seen Jody.
8 other listeners too. So
Oh, we got
who's hiding?
Shout out to the Anons. I didn't see you down there.
I'm certain one of them is probably Sydney.
Oh,
Dinosaur boy.
could be his alter ego, Globe Chick. Tag your favorite Globie.
No, earlier Peter was talking about how something could have mass, but if it was rigid, it wouldn't be in the shape of a sphere. So I wonder what his argument would be against that. I didn't get to stick around.
Well, he
Well,
said
at a distance, everything's going to be a sphere, right?
he said
The
that
light, anyway.
he said that gravity makes the mass turn into a sphere or something like that.
Well, that's what everybody says in Newton gravity, whatever.
So, how do what is salt and sugar crystals? Why they're squares? Why are they square? Why do they call them building blocks?
Because they're lame. They're square. I'm joking. Yeah, they're sentient, right? They self-produce and self-replicate. They just grow without water or anything. It's pretty cool. Or maybe they suck the moisture out of the air. I don't know, really. I'm trying to sound smarter than I am, but I did post in the chat. It's Scanner Guy 1968. And heads up, the guy is a Glober, but he takes some awesome photography. But yeah.
Appreciate it.
Hey, Nick, if you don't mind, I just wanted to say, you know, on the YouTube side, I've been trying to build. It's still RGRs, but it's Truth Connects Us. I got a little brand and a website I'm trying to build. So you guys feel free to come over to the YouTube side and check it out.
And there you go. Are you done promoting yourself? You got any more commercials?
On ABC midnight. I'm joking.
All kind of Glovers had a lot to say about the celestial theodolite when Shane was posting it earlier, and coming at me and everything. So I went ahead and reposted the space and asked where all the globe defenders are on the celestial theodolite. We'll see how many actually show up.
Man, they're not going to show. What are they going to say? I mean, they won't even agree. They won't even agree that a refracted image can't block a light.
Well, the biggest argument I'm getting is, oh, you're using stellarium and GPS coordinates. Everything is based on a globe, so therefore all your predictions are for a globe. That's the biggest argument I get on celestial theodolite now.
You're using globe math. You're using globe stuff.
I do see someone in the audience from last week. I don't know if you talked to him yet.
Who's
Four
that?
Dots is down there.
Who?
You guys see him? Four Dots?
He's been in. He was in. I don't know.
Yeah, he's a flat earther.
Yeah.
He's been in tonight? Okay. Just checking.
I don't know if he's been up here tonight.
Hey, Ken, I wanted to ask a question about the celestial theodolite kind of progress, how it's going first. And second, I did want to ask, like, when stars are going off into the distance, right? And they get toward the horizon and they kind of, you know, it looks as if they shrink. We know they don't, but is there a way to measure like very, very distant mountains and the stars in the background to those? And would it help progress any of the theodolite stuff?
Well, they're
I mean,
using the mountains to occlude the stars.
Mhm.
It's just a timing measurement, what it is. So when the star is occluded by the mountain, that's your time. Then you go find that star and find out what the elevation of the true position of that star from the mountaintop matches the flat Earth prediction. Every time, I don't know what you're talking about, the horizon.
I guess maybe let me say it like this: like a mountain in the foreground, closer to you, versus one that you could zoom in on that may be 100 miles away and try to differentiate if the timing is different in the distance. Like, shit, I'm trying to ask the right way. The second it disappears, checking it against a mountain that would be like if two people did it at once, and see if there's a timing difference, and that may be allude to a distance factor being, so Globers could see that it's just a distance thing and not like a turning of the globe thing. You know what I mean? Hopefully I said that right.
If you have two different observers in two different locations, they're going to have different timing measurements every time, because your distance to the mountain and the difference in elevation between your position and the mountain.
Yo, how do we
are
keep
the two
letting this
sides
guy
of your
talk? You guys
triangle
keep
that
letting
you're
RG
getting your
talk.
angle to. And all you're doing is
probably killed
like when he did that first one, okay? His distance of 50.7 kilometers
I don't know,
plus
man. I'm
his
reading some
difference
patents, waiting
from
for
his
something important to
elevation
happen.
I think Alan
to
already
the
done this.
elevation of the mountain peak based on plane trigonometry.
Oh yeah, a
he
long
has
time
a
ago.
2-degree 31-minute
Usually, whenever we let
angle
RG speak, it turns to
to that
dog shit.
mountaintop from his
So,
position.
Yeah,
And
pretty
when
much.
that star disappears, it matches that angle so that it's like a straight line. Now, if I put you at 40 kilometers away from that mountain, that star is gonna disappear a lot sooner for you than it is for me. You see what I'm saying? Because you changed the angle that you're looking at. So if you're
I do.
closer,
I get you.
right?
Mm.
If you're closer, then the angle to that mountaintop is going to be greater than 2 degrees 31 minutes. So there's no way to
Sure.
compare yours with mine. It's just two different observations. Does it match? Does it match the FE prediction? If the Earth is a plane, then that's just a plane trigonometry equation that you're using to determine where that mountain actually is. You're not measuring it. You're not getting a theodolite and measuring the angle to the mountain. You're not doing any of that. All you're doing is just saying, if the Earth is a plane, and this is the difference in elevation, and this is how far away I am from the mountain, what is my angle to that mountaintop based on that? Now, if it was a
Gotcha.
globe, then it's you want to be far enough away from the mountain so that curvature should be in effect. It's going to make it different. If you're really close to something, like if you say, "Oh, I'm going to use this building that's 2 miles away from me." Well, the curvature difference in 2 miles for a globe Earth and a flat Earth, there's not much difference. You're not going to get something where you can say, "Oh, that's definitely closer to flat Earth than it is globe." So you want to be far enough away where curvature has to be accounted for. But if you have two different observers, they're going to have two different timing measurements.
Understood. One last question before we move on. So if we are taking that into account, what you just described, but we have two observers with two cameras, right, at the same location, they're side by side. One of them's looking at a mountain in the foreground, one's looking at one in the background, but the height difference, let's just say if we found a location where the much further away mountain is taller and the foreground mountain is shorter, but they are optically the same height, and then you do the measurement in a straight line with one star, would that help or change anything?
Well, either of those mountaintops are going to be in a straight line to where they're both 2 degrees 31 minutes. And it's going to disappear if you can see both mountain peaks. I don't see how you could do that. But if one appears to be higher than the other, then it's going to be the one to occlude it. I mean, it can't disappear behind the closest one. And then you say, okay, now let's see when it disappears behind the farthest one, because you can't see the other mountain. If you can see the other mountain, it's higher, and it will occlude behind it, not behind the one in the foreground.
That makes sense. Appreciate it, man.
Jesse's out there telling everybody that Dr. Heffron is modifying all of the measurements to match a flat Earth.
Yeah, well, first he said that it was too messy and that it was outside of mean deviation, right? So then Dr. Heffron, spurred on trying to do his damn do-gooderist, was like, okay, bet I'll apply a nice quick azimuth correction, put that peak exactly where the globe predicts it'll be to give my globular friends the benefit of the doubt, calls it a J correction in favor of Jesse, applies it to all the data, and it straightens out and aligns it with even more. But it's not required for any of the points to align with flat Earth, and it doesn't make any of the globe points align more than flat Earth. It doesn't do anything except clean up the data. And when you completely remove it, it doesn't change the results at all. But regardless of having 6 different people explain that to Jesse 5 different times, he chooses to run with the story that you just said, because that at this current moment is the best defense the globe has against this, is to religiously, vigorously lie about it.
Yeah, well, most of these people coming at me with that crap, they're listening to him.
Yeah, most people don't have a rebuttal. They just know that we're wrong and it's stupid and that Jesse took care of it. Like what Jesse said, or what math he used, or which points that were weak that he thought, none of that matters. None of them know. Nobody could repeat it if you ask them. All they know is they don't have to worry about it because Jesse.
Yeah, they try and wrangle me into going back to square one and going through all these presentations with them. And I just give them a link to Alan's YouTube for the celestial theodolite. Tell them, hey, start with the first couple, and watch some of the other ones to catch yourself up. 'Cause I'm not sitting there explaining it to 5 different people.
I mean, it did get complicated because it's a work in progress, and he keeps adding ways to make it improve, like to improve it, right? But the basic method, I think, gets lost because they just make it more complicated and ask questions and bring it back to the observer angle and try to add in refraction desperately. But I took today and I made a new diagram for it, just like from scratch for me, for my understanding with the math that I could do, so that I could understand what was going on. And I took took inspiration from his last slide, and I removed the stuff that I thought was superfluous. I didn't label anything on the right so that optical angles don't get confused. I just left the geometric refracted globe Earth prediction and the flat Earth prediction. And then once you get the angles for those 2 different predictions, right? Because the globe Earth would be lower because of the time and the distance. Once you get the angles, you can just use trig again to estimate the elevation of the peak at the time of occlusion, and that's the data that he actually graphed. But I put what I made in the nest for you to check it out. It's like I think a simpler way to look at it, but I mean it's all the same. I think if you can reduce it to one example, I think people will understand if you go through all the steps for one point real quick.
Well, I just don't feel like going from square one with people that can't even tell me the basic premise of the experiment.
Yeah.
They don't know, and I mean, they literally know nothing about it.
Well, there are people
but they can tell me it's wrong.
Yeah, there are people on step 7 of debunking it who actually I decided to, oh, wait, can you just outline the process briefly as you understand it? And they're like, yeah, so you measure an angle. I'm like, wrong, already wrong. Like, nope. Obviously, you have no idea what it is, but you clearly understand enough of it to debunk it. That's hilarious. So that's definitely where we're at. The other thing you can ask them is, what's the difference between a celestial theodolite and a regular theodolite? And if their answer is anything but one we made up, they're also wrong, right? Because there's no such thing as a celestial theodolite, but there are people who are like, no, I bought one. Here's a link, right? You know, like, here's what it is. It's like, no, that's a telescope with a zenith mount. No, that's a transit device. What are you guys trying to do? Stop it.
I want to ask this for my own understanding. I don't know if it's necessarily the premise, but just help me if I'm grasping this right. The idea of the celestial theodolite was to assume a flat baseline just for the sake of arguing. And then when he made his observation, he went into stellarium and made the secondary observation at the same time from a different location to see if the star would have been in the same spot. And he turned off refraction, and when he turned it off, it was exactly where it was supposed to be, confirming a flat baseline.
Well, it's what the experiment is just hypothesis testing, right? So the hypothesis is that the Earth is a globe. Well, he's testing the null hypothesis, right? So if when he went through his null hypothesis before, he was talking about when you are in school, you know, you have to have a hypothesis and test your hypothesis. Well, you can't always. I hate to use the word prove, but you can't always prove your hypothesis true, right? Sometimes it's difficult, but you have a null hypothesis, and if you can disprove the null, then that's you've accomplished something, right? You haven't proven your hypothesis, but you've disproven the null hypothesis, which makes your hypothesis more likely. So this is nothing but null hypothesis testing. So instead of saying the Earth is a globe and I'm going to prove it's a globe, he's saying, oh, we're going to assume that the Earth is a plane. And then I can disprove that hypothesis by taking these timing measurements. Well, it didn't work out that way. You can't disprove the null hypothesis. They keep matching. So that's the basic premise behind it.
So he assumed a flat baseline then?
Right.
Am I
And
correct?
the angle,
Okay.
yes, he assumes a flat baseline. And what he's doing is he's just getting an angle to that mountaintop, the actual position, right? We're trying to do it without refraction.
Right, because I mean, locally it's flat, and all he did was just extend the baseline forever, right?
Right. Well, he just extends it to the mountain. From him to the mountain is a straight line. And then the
Right.
difference between his elevation and the mountain's elevation is the opposite side, and he gets his angle from that. It's purely calculated, right? There's no measuring involved. It's just saying if the Earth is a plane, then the actual position of this mountaintop from my position is 2 degrees 31 minutes. So when you wait for the star to be occluded, that means that the mountaintop has actually blocked the light. That's your timing measurement. Now you find out what is the actual position of that star. That's the purpose of turning off refraction. You don't want the apparent position. You want the
And
actual position of the star.
don't when that with that altitude in the sky of the star and the mountaintop, they would have assumed like a shit ton of refraction, right, off in the distance or whatever. Was that something else that was like predicted by the globe or used by the globe? But like when he turned off refraction, it was like, oh my god, what the fuck?
Yeah, it's still like, oh my God, what the fuck?
Well,
Why
dude,
nobody's brought up a serious contention with it.
An occulted star can't be refracted. Like when he was trying to devise the method, he was like, how do I remove this unfalsifiable bubble wrap that this model has called refraction, where they can retroactively employ a coefficient no matter what the circumstances to raise everything back needed to bring it on the globe. So his goal was to remove that, and he did so with Well, if we don't look at it, right? We're not looking at the angle. We're not taking a measurement of where this star is. We're looking at the time it was obscured by this mountain, and then we're going to look at, well, based on the almanac of stellarium or whatever you want to look at, where was this star at that time, and you get the elevation, and that's the elevation he's comparing. So he tried to simplify it to remove the refraction element completely, which is why they're like, without refraction, the globe loses, right? So they're trying desperately to bring it back in, make it about all things that it's not, and then try all sorts.
Without when he turned refraction off, that star should have been a lot lower in the observation in stellarium, right?
Well, the angle that we would predict it is not where it is in reality, which means the elevation that you used to predict from the basic trig for the globe is wrong all the time. And which is when he figured this out, and that's why he made more observations. He was like, "Holy crap, the Earth really is flat!" Because every time I do this, it comes up with, look, the flat Earth elevation angle is just the baseline, and then
Not every time. We got to be fair. He did have some statistical outliers where they were just like way the fuck off. I think he had one that supposedly matched the concave Earth or whatever.
No,
but I mean, I know what you're saying. Like it was a statistically significant, like well over the standard deviation of
Is that the one where he
everything
said
aligning with the
something
flat
about
Earth.
a cloud?
nothing matched concave Earth. That's just something Jesse says.
Yeah.
Oh, really?
Yeah, no, it's not a thing
Yeah,
that
you have to
actually
be
happens.
careful
hilarious.
you got to be real careful of what Jesse says. Jesse will
Nothing
tell you
matches
things
concave.
that are just absolutely untrue.
Oh, I know. He comes in all friendly, and then I see videos with him talking to somebody else, watching option. Did you get that plane? Did you get that plane?
Well, so
We got him now.
There
wasn't
wasn't
so fucking cheesy.
There wasn't
the
any.
measurements that were off, weren't those the ones where the stellarium had the azimuth wrong?
So no, there was only like one mountain where the elevation kept coming up wrong for both sides. To be clear, it was funky for both sides. That one data point didn't prove concave, didn't prove globe. The elevation was off of that mountain, which was an outlier, right? So that's what that was. Nothing to do with it's all invalidated. It doesn't work anymore. Like definitely there was something going on with one peak where some elevation was not accounted for correctly because it was wrong on both models wildly. So that doesn't prove either way. That's just something that he had to fix. And I think he ended up fixing it, but I forget what happened with that one. What you're talking about, Ken, is the J value. Again, the azimuth correction is based on him correcting the data afterwards as an entire aggregate data set to refine it closer to the globe prediction for the point of the peak so that the azimuth is exactly correct. Because you don't really know if it's occluded by the tippity top of the peak, the right shoulder of the peak, the left shoulder of the peak, right? And those have slightly different elevations which correspond to slightly different time. That's what he's correcting with that. And again, that's the J value. It has nothing to do with changing the results. It's cleaning up the data in aggregate. So that as we decide to turn that off completely and we just work with the raw data, it has no effect at any of the points. So none of the points line up with globe Earth. That's really the takeaway. And what he found in doing this method was that, hey, every time the globe exists only in this refraction correction. Right, it's not a prediction; it's a correction after the fact, and that's what brought Dr. Michael Heffron over to be a flat earther, right, all by himself. He was like, "Hey, this model exists only in these mathematical arbitrary corrections." Boom, here, that was over.
That's what I thought. Jesse said in a statement, and I'm not quoting him verbatim, but I'm quoting him just in the gist of it, right? He said that he did the same thing that Dr. Heffron did, except he made it better. And when I heard him say that, I'm like, how the hell are you going to make it better if you did it exactly the same way as Dr. Heffron, unless you changed it?
He changed it completely. Has nothing. By the time he was done, it had nothing to do with what we were doing. He made a GeoGebra simulator where he called what was the flat Earth Heffron angle was really just a refracted globe angle plugged in at both sides, so that he could manually add the optical refraction back in, so that he could make the angle what it would need to be to get the globe. So debunking that nonsense thing is how we learned about the celestial refraction coefficients, the G.G. Bennett formula applied before negative 15 degrees. And that how you get all those ridiculously best fit curve fit coefficients that you literally force planar measurements into a curve using that correction. So he did a completely different thing that was still useful and cool that had nothing to do at all with what we were doing. And then he went around telling people that he fixed it and that he could predict globe stuff with it. It's the most disingenuous, like insincere horseshit that I've ever seen a person do. And that's why Jesse's blocked and nobody wants to talk to Jesse anymore.
very disingenuous. I think it was D3 saying that. Is this what you're talking? I don't know, man. His arguments. I mean, they're not even close. He uses the wrong. I mean, it's just all over the place. But D3 was saying that he came up with something that Heffron had to reconsider some stuff or something. I don't know.
Yeah, no, he made some observation about a particular counting thing when he was trying to figure out it was the left shoulder or the right shoulder of the peak. One of the other ones was, oh, is this the right peak? He was trying to get the frame rate down for how the field of view was working with the specific instrument. Like just the nitpickiest things. None of them changed anything. He never had a point. All his rebuttals were questions. At the critical point when we were like, okay, what did Dr. Mike just say? He had no idea. He wasn't listening. Doesn't listen to anything that he's saying. He just says, I don't know. He rambled a bit and then he said his next thing. And that's what it's like talking to Jesse, right? So you're trying to have like a meaningful exchange. He's not listening to you. He's not trying to listen and absorb your position and truthfully, honestly judge it. He's just trying to figure out the best course of action to fudge the globe and discredit whatever you're doing in any way possible. So
I think he actually said that one time that he wasn't listening.
Yeah. We had it recorded and we clipped it out because it was like after 3.5 hours on the 7th day, right? The sun, like in the Battle of Mordor, Gandalf came and been there for hours, and like he came, Dr. Heffron came with like this final like succinct summary of exactly what his position was and how, and then Jesse was like, I wasn't listening. Here's my next thing, and we were like, nope, boo, shut it down, get off the stage, shut up, Jesse, you're done, that's it.
Hat tip to Galatrax for asking him the Steel Man.
Yeah.
What Dr. Heffron just said.
Yeah.
And Jesse wound up saying, okay, well, what did he say?
Yeah, not once did Jesse actually approach the geometric consequence of the predictions for one peak. All he would try to do, like he completely changed the method. Like I said, took our arctan of rise over run and made it something else where it isn't, and then called that the Heffron angle. Like he added in optical refraction and then used the geometric Earth curve and then subtracted it back out and did all sorts of shit.
He added a correction in.
Yeah.
He added a correction in.
Yep.
A correction equation.
Yeah, several. Like he had G.G. Bennett, he had regular terrestrial, he had celestial, he had rise over run.
I thought it was just like one that he did or whatever. Maybe one or two or whatever. Several.
Yeah, several.
In all of this, he's still ignoring the premise of the experiment is to disprove the null hypothesis of the flat Earth. He keeps on, but I can get a globe out of it.
Yeah, it's honestly, it's like the most smarmy shit I've ever seen.
But I can get a globe out of it.
Yeah, but his goal is to just kick up enough mud, make enough stink, like make it, nebulous enough where other globers can do exactly what they're doing now and go, I gotta worry about this. Jesse already handled this. He talked for 3 hours on McCune. I know he said something. I couldn't tell you what it was, but he said it for a long time, and a lot of people watched it. So I know you guys are dumb.
So you guys are dumb.
Yeah, that's what we get.
Right? Way it is too. Yeah, I can't even deal with Jesse.
No, I refuse to.
I got him. I got him. Him and Mordwan. I even blocked Peter too. He's lucky his alt doesn't get blocked. He's
I like Mordwan, but he did pay me $10,000. Maybe I'm biased.
You're kind of biased.
I have a
even
soft
though
spot for it.
That was the reason. Even, but yeah, I mean, I can't believe he did it. But yeah.
Sure. Definitely a first.
He was supposed to pay me $10,000 to argue against flat earthers.
You guys remember the old days with Jesse? You guys hadn't quite caught on yet, or a lot of you hadn't, I guess. And I put out that little video. It's on my BitChute channel. It's all about those who worship at the altar of the golden theodolite. Way back in the day when Jesse was working with tractor feed paper and felt pens, talking about his theodolite measurements 105 miles away.
Talking about my Thea. I remember.
And I cut him to shreds and said, I do not want to talk to this guy anymore. Have you heard any of his rebuttal? He just completely lies. He's just totally tertiary to any of the facts. He doesn't talk about any of the points you address. I just shut him right the fuck down. Was not ever going to talk to him again. You guys like, well, maybe we should talk about this other subject.
No,
and what if he's And now you guys finally are full circle and on board with the stone train regarding that ass.
Yeah, he's a terrible person.
Well, he sucks you in because he's just, well, and he's all soft spoken and stuff. So you're like, well, maybe I can put up with it. But yeah, he's just a dick and a liar.
He's the worst kind of liar. Like he'll be told literally like something 7 times, and tomorrow he'll be like, you know what? No one's ever told me, and he'll repeat it like it's the most. You're like, what? But I was there yesterday with you, and then once that happens 7 or 8 times, you're like, you know what? Fuck you, Jesse.
Man, I think even Dr. Heffron's getting to that point.
Yeah. All right, I think I got to bounce. I think is Witsit doing a stream on his debate review? I think maybe he's gonna have participation with that.
Hey, it could be. Yeah, it's nearly midnight here for me too. It's been fun, guys, as usual.
Well, I appreciate you stopping by.
Thanks for running the space
Have a
all
good
day.
one, y'all.
Jeez.
Got to do what you got to do, man.
I was listening earlier. You guys were entertaining me when I was at work for sure.
We've chased off Franco. I was hoping he'd come back.
Uh-oh, Four Dots has his hand raised.
No, what's up?
He's gonna fuck everything up. Watch.